Good morning everyone, I am very happy to have this chance to give my presentation. Before I start my bit, let me introduce myself first. My name is Đỗ Như Tài from Vietnam. I am now studying in Cheongnam National University, South Korea. Today I will share my research with you and the title of my presentation is Affective Aggression Analysis in the Wild using multitask Temporal Statistical Different Model. Okay, let's start. Let me introduce the outline first. My presentation will be given in 5 parts. Introduction, objectives, report method, experiment, and discussion, conclusions. Well, let's move on to the first part concerning about the introduction section of my research. Affective behavior analysis in the wild. Maybe you are very familiar with it. Focus on helping the machine to be able to understand the human emotions. The emotion target is to detect the emotion representation of specific person in the given video. It is to describe by the continuous by using the 2D valence-arousal emotion wheel, indicate the level of pleasure and affective activation. Besides, the emotion representation also to describe by 7 basic emotions such as neutral, angry, disgust, fear, happy, sad, surprise. Some related using multitask different models with channel locks plus ABAW plus fully coded layer, and the output is valence-arousal aggression actioniness. They use the ABAW dataset for their research. It is the large-scale dataset collecting the whole in the wild videos from YouTube with the wide range subjects about age, ethnicity, profession, hippo, elimination conditions. In this study, we focus on the ABAW Challenge 2020. It consists of 3 tracks. The first track is about valence-arousal estimation. The second track is about 7 basic aggression classification. And the final track is about a action unit detection. Some challenge in the upper 2 datasets. Firstly, it shows a variety of age, both elimination, occlusion, and in the wild element. Furthermore, it is different to distinguish the emotion, such as happy image here and neutral image here is nearly the same, but happy here and happy image here is a little bit different about the emotion category and valence-arousal values. It's other problems. From challenge, variety of appearance as well as valence-arousal change among frames, leading to ambiguous if written separately frame by frame. Example, the current frame for recent surprise emotion is and different neutral emotion categories, but nearly same valence-arousal is the ambiguous. And neutron and neutron is the same category, but bit different in valence-arousal value here. So, our study in this study is express emotion relation among current frame and developed by fusion of statistical and temporal differences and multitask learners for solving the ambiguous. Next, we will talk about report methods. Firstly, we change phase feature model. We use Affective dataset and return weights from VG2, VG1 or charts. After that, we try for learning and function against TP. The highest accuracy achieved on freshness 50 model. Using return weight VG phase 2 and accuracy is 62% and RapTP accuracy is 87%. Secondly, we use phase detection and tracking under from for instruct phase frame by frame. We use 3D phase detector with tracking by detection and Hungarian matching methods. After that, we use observation feature SV chronohistogram side motion phase encoder. In phase detection fails, we apply interpolation phase position based on reverse and net frame coordinate phase. For our model architect, we have for log input feature learned and output. For input log, we have reverse log with S frame as set to 32 in our studies and current frames. For feature log, we use phase model return on affective and Affective for exact property and phase features. For learning log, we use LSTM module extract temporal filter from various logs and statistical module extract statistical features. And finally, we use phase model extract from current frame for phase feature and properties features. After that, we input to classroom log for reduction arousal valence mean-square-error, valence concordant correlation coefficient, arousal concordant correlation coefficient, and ocean categories. More detail about LSA module. Proposed is average temporal filter by direct frame over the time. Input is the phase frame 1 to frame keys, and using phase filter model for filter extraction. After that, we use LSTM to 1 or 2 layer for extract temporal filters is here. Next, we use statistical module for isolate the statistical filter among phase filter from real frames. The input is frame 1 to frame key, and we use phase model for extraction rubrical on 7 motion. After that, we use statistical operator max min average for output statistical features. For the last sentence, we use mean-square-error loss for arousal and valence equation here. Concordant correlation coefficient loss for every arousal and valence equation here. S means covariance, sigma mean variance, and H mean average operator. Category loss and TB for 7 basic emotion equation here. And lastly, total loss equation here. The weight of classification loss is highest because I want to boost change in lesson loss. Next, we focus on arousal and valence distributions, and finally lower priority in mean-square-error loss. Classification loss, there are 4 ranges for arousal and valence mean-square-error, arousal distribution and valence distribution, and category loss B for emotion category. Every range has 1 or 2 layer and dropout layers. Next, we will talk about experiment and discussion. Emotion metric check 1 will use valence arousal reaction score, coming from concordant correlation coefficient equation here. Check 2 will use basic emotion correlation score, coming from F1 multiply 0.67 plus accuracy multiply 0.33. After study, there are 6 models in our research. Model 1 and 2, we only input image. And model 1, non-multitask learning, and model 2 is output erosion, valence, arousal, multitask learning. Model 3 and 6, we use reverse log. There are 32 frames in reverse logs. Model 3 and 4, we use only statistical module. Model 5 and 7, we use statistical module plus LSTM modules. We will discuss about reason on valence sets. The first slide is baseline model, and the remaining slides there are reason on 6 models in our study. And on a cycle, so multitask is better than non-multitask. The model 1 and 2 is the same structure, but model 1 only output erosion, and model 2 outputs erosion and valence and arousal. And the accuracy model 2 higher than model 1, and the same model 4 higher than model 3, the model 6 higher than model 5. VA score increased when use statistics module and LSTM module. This is cycle blue with blue color. As you can see, the model 3 is only input image is a lower than model 4 and model 6 input from reverse loss. And the highest average score achieved at model 2 or only input image and multitask learning, and highest VA score achieved at model 4 with statistical module and multitask learning. And fusion as overall 6 model achieve best average score 0.54G, and Poison 2 in VA score at 0.527, lower than model 4. Here. Next, we will discuss about result on test sets. For check 1, we use model 2 for 6 and fusion overall for submission, and we achieve VA score highest as model 6 with 0.382 score. And model 6 is mean we use module LSTM and statistical and multitask learning. Check 2, we use model 2 for and functioning a little bit model 2 and fusion overall model. And we achieve the experience score highest as model 2 modified a little bit with 0.389. Finally, we would like to summarize our presentation. Firstly, we present statistical and LSTM module applying affective behavior analysis in the wise. Secondly, multitask learning gave the better result on average score with fusion between control, valence, and emotion. And the statistical block gave the better result on valence-arousal score. Finally, our team achieved the position for in check 1 and check 2 in the ABAW Challenge 2020. Thank you for listening.